listen please. No. Now look at the board, please. This is always going to be the first question of the 3 that you've got to do, and you've got to get 2 correct. Okay, this is a standard question, and the important thing here is it says the word probability. Probability means there. This word means your answer is going to be what? A decimal, 4 decimal places, and that decimal value is going to come from your chart in some way, which gives you 4 DP answers. Okay, so the first thing you do with all these questions is you quickly sketch it up. 178 goes there. 172 goes there because 172, funnily enough, is smaller than 178. And 190 is way over here. And we want to work out the probability of all of that. That is the first bit. That probably was caught nicely on the microphone. So this is what we do next. This is for anybody who doesn't get it the first time round. They can watch it again. Now, you are going to struggle. You are going to struggle a lot if you can't get that out of this. If you cannot get that diagram out of this description, you are destined to fail this. End of story. Let's get it straight out there. Okay? You are not going to come close. You are going to get it basically wrong because you're going to work out the wrong thing. Yes? Probability of being between 170. It's the question. Okay? Now, so I gave you this one for starters because 172 is to the left of the middle, 190 is to the right. So we need to work out the area, the probability in there, and add it to that probability in there. In other words, we do the problem, we repeat it, and then add the 2 answers together. So we've got to work out what is 172 as a Z value. 172 is not in our tables, but we have to turn the 172 into a Z value, and you do it like this. It is 6 away from the middle. It's 6 away from the middle. The standard deviation is 7, so therefore 6 divided by 7 is the Z value. And 6 divided by 7 is 0.857. Now, 0.857, it's actually negative that because it's to the left-hand side, but the negative doesn't matter because we're only interested in the area and it's symmetrical, so we don't need to worry about the negative. So 0.857 is 3dp because your tables can use 3dp. Now, 190, while we're at it, is 22, no it's not, it's 12 away from the middle. 12 divided by 7 is 1.714. There's your 2 Z values. All we have to do now is to look up the Z value in our tables because that gives us the area. Look up the Z value for the 1.714 in the tables. That gives another area. Add those 2 together. So this is what I did. Here's the tables for the first one. What are we looking for? 0.857. The table's 0.85. So therefore 3023 is our starting number. And 7 is way over here. There's 19. And so therefore, if you add 19 onto the 0.3023, you get 0.3042. 0.3042. So hopefully that wasn't too quick, but we've been doing that for days now, so it should be okay. So that number, 0.3042, I usually write it like this. I put an arrow like that. 0.3042, because then the person marking it, me, can see that you've looked up the right number and got the same area that I did. Okay, 0.3042, I put an arrow there. Then I do the same for 1.714. I go back to my tables, which are down here, and 1.714, so I take this thing here down to 1.7, which is that row there. 1.71 is this one here. So that 0.4564 and then 4 is this one down to there, and that's a 3. If you add those together, you get 0.4567. Easy. If it's 0.4567, then that was not what I wanted. 0.4567. All we have to do to answer the question is to add those two decimals together. There it is. Probability equals that plus that, which is 0.7609, is it? Yep, 7609. And guess what? How much room for another number in this question is there based on what I've just done? None whatsoever. You should get exactly that. You should get exactly that. You should get that from the tables. You should get that from the tables, and you should add them to get that. There is no error because you're all doing it using the same method. You should get exactly that. And it all comes from drawing this diagram right in the first place. Yep.
Did you run through getting those blue numbers?
The blue numbers, yep. The blue number, all I did was I said, how far away is 172 from 178? 6. Divide the 6 by the standard deviation. There's your number. It's the difference from the mean divided by the standard deviation. That's it. Okay? Now, let's have a look at this, the second sort of question. Let's have a look at the second one. What proportion of people? Now, notice, gentlemen, that I used proportion. Proportion and probability, and I'll talk about the difference between these two. But let's first of all work out the probability of being over 200 under these circumstances. Now, all we do is we do our diagram, 178, 200 is way out there. 200 take away 178 is 22. 22 divided by 7. 22 divided by 7. 3.14, is it 2? It's actually 3.143, but you're lucky it doesn't make any difference. Note that you've got to round that 2 up because the next digit is 8, I think. Make sure you don't not round here because that'll cause a slight error in your answer. So 3.143 actually is what it is. Now 3.143 is way out to the right, which means we expect the probability to be bugger all. Remember, 3 standard deviations. Inside 3 standard deviations is 99% of your population. 99% of the population is going to be there, which means only 0.5% is going to be higher than that. And we're already at 3.14, so we expect it to be quite small. So 3.143. We look up 3.143 in the tables. What do we get? Answer 0.4992. Now, we don't want that 0.4992 is that. We want that bit, the bit that's on the other side. In other words, we want the bit that makes that up to 1/2. Now, you shouldn't need your calculator to go 0.5, take away that to know what it is. Because if you look at this, we obviously need 8 way over here on that last digit. We need 8 to make it up to 0.5. So therefore, automatically, 0.0008 is the probability of being higher than 200 centimetres. Now, if you did it on your calculator would automatically change and give you some crazy looking thing like maybe that.
Yeah, well, it goes 8 times 10 to the power minus 4.
Yeah, same difference. Yeah, if you want to, yeah. But your calculator generally puts things into standard form. 8e minus 04 means that if we start with an 8, we need to move it 4 steps back. That's where the decimal point really should be to turn it back into a normal number. So if you ever see 8e minus a number, then just imagine moving the dot from in front of the 8, 4 hops back, and filling the gaps with zeros. And it's obviously the same thing. Your calculator automatically does that to really small numbers. Okay? Now, here lies the question. What we've done so far is we found 0.0008. That's not the proportion, that's the probability. And the difference between the two words is this. A probability is a decimal number from 0 to 1. That's what probability is. It's that number that comes off your chart. Okay? A proportion expects you to give a percentage answer. So therefore, if the probability of something is 0.5, then the proportion equivalent to 0.5 is what? 50%. If the probability is 0.1, the proportion equivalent is 10. 10%, 0.1 mean the same thing. But the question asks for the proportion, so you're expected to work out the probability and go, therefore, the proportion is this turned into a percentage. Now, the easiest way to turn a number into a percentage is to move the decimal point 2 hops to the right. That's all you do. So this is 0.08%. And that is the correct answer to this question. 0.0008 means you've done the correct calculation, but 0.08% is in fact what the question asked for. Okay, moral of the story, question number 1, if it says probability, write a decimal. I mean, what would be the percentage for this, for number 1, if it said what is the proportion? 76.09. Simple as that. This, if it was a proportion question, you would write that. You wouldn't round it off, because percentages are allowed to be decimals as well. You would just move the decimal point 2 over and say it's 76.09. But that question asks for probability, so you write down a decimal. If the question asks for proportion, you write down a percentage. Simple as that.
So when you find the percentage, you always move the decimal place 2 forward.
Correct. That's all you do. You just move it forward 2. Yeah.
0.0008. Oh,
It's 0.5, take away this. Okay?
Are we going to the next one?
It's the rest. Now, I'll do the last one now. Using question number 2, question number 3 might be like this. Or use question number 1. If 20,000 people were in this survey, how many people would you expect? How many people would you expect to have a height between 172 and 190? How many people would you expect? So this question doesn't ask for a probability. It doesn't ask for a proportion. It asks you for how many out of the 20,000. How many people? What number?
76.09.
Hell of a lot more than that.
15,180.
Correct. How did we get 15,000?
20,000 times 0.76.
Right. Answer to question number 3. 0.76 is the probability. That means 76% of the survey. Can we stop doing that? It's just annoying since you're so lame at it. 76% of our survey were in that range. That's 3/4, a bit more than 3/4. How many people were surveyed? 20,000. That means a bit more than 15,000 people must have been in that range, because 76%. Okay? If we want to know exactly, we work out, all we do is we take the probability, 0.7609, times it by how many people that there were. 0.7609 multiplied by 20,000 is exactly, George, how many? 15,218. Was there any decimals here?
No.
That was it.